Okay, so the first section we're gonna study is section 2 of chapter 3, addition of whole numbers. Um, yeah, for chapter 3, we're gonna work on whole numbers. And the first operation that we're gonna work on is addition. And let's talk about whole numbers or number system first. So here is a Jamboard that I'm using. I heavily use Google Slides and Jamboard. Jamboard is in Google, just in case you are curious what's going on here. um, yeah, they provide this whiteboard. It's different from Smartboard. Smartboard you can scroll up and down. The only bad thing about this Jamboard is you cannot scroll down. You need to write everything in this full screen. But good thing about this is you can access to this from anywhere. You can invite your friend and you can share this document with anybody else, just like Google Doc or Google Slides. Okay, so here we are. Hold on, let me move this one. Is this right side? Okay. So if you remember from Math 137, we talked about number systems a lot of times, right? So we started from counting numbers, right? If you guys remember counting numbers, what numbers do you count from? Count from 1, 2, 3, 4, 5, right? So 1, 2, that's what little kids do when they start counting. So these are counting numbers, or we call that natural number. Okay, so 1, 2, 3, 4, 5, 6, 7, da 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 da. And then we are adding a certain number to make whole number. So whole number needs to have what number? Yes, the big fat 0. It's very important number, right, in our number system. Yeah, 0, 1, 2, 3, 4, da 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 is called whole numbers. So as you can see, the Venn diagram here, natural number is a subset of whole numbers, right? We're gonna increase this along the way. Okay, so but we're gonna start from these whole numbers. So we're gonna work on these numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, da 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 da. Okay. Okay, so let's go back to this chapter, section 3. Okay, so addition of whole numbers. Here are some objectives that I'm focusing on. So number relationships, including comparing and ordering within whole numbers. So even if I didn't write whole numbers here, you need to think about which number are we talking about here. Number relationships, which is greater or less or equal, and you can order them. And you also need to know the meaning of addition, okay, using various models. There are several models that we're going to talk about, so you need to know all the models. Properties of addition and how to use them. So for example, like identity property, inverse property, commutative property, associative property. You have heard a lot about those, right? So you need to understand what each of those properties are and how you can use them. And there are algorithms. Okay, we can ask students to invent their own strategies to add using manipulatives or using different strategies, but also they need to know the algorithm, right? More standard and traditional way. You need to know all about that, so including the standard algorithm and how to use them to solve problems. And also we're going to talk about mental addition, computational skills, and estimation. Okay, so the first model that we're gonna see is set model. Set. So you have one set and two sets. You're gonna combine them together. Then you're gonna have the one whole thing is one whole set, right? So that is a set model. So here is one example. Suppose Jane has 4 blocks in one pile and 3 in another. Can you imagine the picture? of one pile of 4 blocks and 3 in another, just like this. So 4 blocks in one pile or in one set and 3 in another set. If she combines them together, we combine them together, then it is not intersection, it's union. Why? Because there's nothing overlapping. No block is in either set A or set B, right? It's gonna be either in A or in B. There's nothing both in A and B. So for example, for block B, it is in A. It cannot be in B, right? So there's nothing overlapping. So the union of these two sets is the whole number. Well, with elementary school, second graders, you're not gonna use this as a set, but in general, we can say that, oh, here's one set of 4 blocks and there's another block. We're gonna combine them together and we're gonna count them all as one whole new set. Okay, so students can count how many there are. So if you think back, Math 137, set models, if you think about the set, this is number of elements in what set? Set A union set B, right? Because there's nothing overlapping, we're just counting these two together by adding them together. That is one addition. You don't have to teach your students with, number of set A is 4, number of elements in set B is 3, and the union. No, that's way too hard for them. But you need to know as the teacher, okay? So here's one set of 4 blocks and another set of 3 blocks. Together, there are 7. That is set model. Okay, just know A union B and N of A union B means number of elements of set A union B. Okay, if your my math lab asks you about interpretation of these. So here are some other examples you can do, like using the counters. We do this a lot of times, right? When you're doing that, we can just have, 2 different colors of groups. So one set with, let's say 4 counters, and another set has 2 counters. Of course, there's nothing overlapping, so we can just count each of the sets and adding them together. That is addition, right? So if I have 1, 2, 3, 4, 5 red counters, and if I have 1, 2, 3, 4, 5, 6, 7 counters, yellow counters, how many counters are there all together? Well, we can now use our counting on or other strategies. You can count on by saying that, oh, that's 5, and 6, 7, 8, 9, 10, 11, 12. Or the other way around, you have 7, 8, 9, 10, 11, 12. That's count on. Or you can do matching up to make 10. So if you read the 10 frame tile article later for reading assignments, you're going to see how you can use 10 frames. But we know that 5 and 5 makes 10. So these two together, that's 10, and you have 1, 2 more. So 10 and 2, 12. So that's going to be another strategy that you can think about. I also wanted to introduce you with this Didex program. This is really good virtual manipulatives. So if you want to know the website, let me know. Because this is my first lesson recording, I'm just gonna pause it here and check if it is well recorded. Okay, I think it is well recorded. Okay, so the definition of addition of whole numbers is let A and B be 2 disjoint finite sets. What does disjoint mean? Nothing overlapping, nothing's joining, nothing is in the joint intersection part. Finite set, it's not infinite, it doesn't go on and on and on. We have a certain number, 4, 3, right? So that's finite sets. Each of them are finite sets and nothing's overlapping. Then number of elements in set A, let that be A, lowercase a, and let number of elements in set B 3, right? B, then A plus B is number of elements in A union B, A union B. Okay, that's what the set model is for. Okay, addition model using the number line. This is a heavily used model, right? So, and we are all familiar with this number line. So for example, let's suppose I have four balls, and my sister gave me 3 more balls. Then we go 3 more from there, 1, 2, 3, and the total number is 7. So 4 plus 3 is where it lands. It lands on 7, so the total number is 7, right? And here's another virtual model that you can use, number line. So we can do the same thing. We're gonna work on only whole numbers. We have negative numbers here, that's integers, but we're not gonna do that. We're just gonna look at from 0, because we are working on the whole numbers. So I'm gonna just put 0 as a starting number, and let's look at only up to 14. And let's look at these. Okay, so if you are going from here to 6, we know that 6, and if you go to the right hand side, and let's suppose you are adding 1, 2, 3, 4, 5 more. So 5 more. So 6 plus 5, because we went to the right hand side, to the right side, we are adding them. We are adding them, right? So 6 plus 5 more is 11, where it lands on. That is your answer. If you do subtraction, you're gonna go to the left hand side. Okay, so we're gonna talk about that a little bit later. But since it's addition, for positive number and addition, you go to the right hand side. We can always add more. So if we want to add another number like 1, 2, 3 more, where does it land then? 14. So 6 plus 5 plus 3 is equal to 14. Why you need to be careful when you are using the number line is, some students are counting from this and say 1, 2, 3, 4, 5, 6, 7. No. And 6 goes here. No, it's not, right? We need to start from 0. And we are looking at the space between the numbers, between the tick marks. So here's 1 space, 2 space, 3 space, 4 space, 5 spaces, 6 spaces. Okay? And think about like bunny hopping. 1 hop, 2 hops, 3, 4, 5, 6. Don't count from 1, okay? All right, so those are some models that we talked about. Okay, so consider Kenzo has 4 feet of ribbon and 3 feet of white ribbon, red ribbon and white ribbon. Together, how many are there? 7 ribbons, right? Common error, some students count from 1. You need to start from 0, okay, to show the number. So be careful about that and guide your students in that way too. Okay, and a lot of students are playing like basic addition games. Yeah, there are, I think, a lot of websites that you can also look for. In one of the classroom I observed, in this first grade, students were wearing a small hat, kind of a hat, and they put the numbers on their head, and they were playing basic fact games with it. So I thought that was pretty interesting, and kids really loved games. So in general, yeah, little kids love games, and I think it's very interactive. So if you are thinking about, making math more fun, you can always think about creating some games or adopting some games. in your classroom. Okay, so mastering basic addition facts is very useful. So here are some techniques that you can do. Counting on. I already talked about counting on at the beginning, right? An addition strategy where addition is performed by counting on from one of the numbers. For example, 5 plus 3 can be computed by starting at 5. 5, 6, 7, 8, right? If you have something like 7 plus 9, I usually go from the big number, 7 plus 9. I will start from 9 and I will use my fingers. I wish I can show you my fingers. But if I use that color counter, let's suppose we are doing 9 plus, what did I say? 9 plus 5. Let's do 9 plus 5. I know I have a 9, but I need 5 more. So I can do 9, 10, 11, 12, 13, 14. Oops, 14, right? I already have 5 counters there. So starting from big number is much easier when you're doing the counting on strategy. Okay, doubles. I already showed you the doubles as well. So for example, 6 plus 7, when you are adding these numbers, we know that 6 plus 6 is 12. So you just need one more to that, right? So we are using the doubles. Okay, so that's easy. We just did 5 and 5 is 10, and you can add more to that. So using doubles is so much easier too. Also making 10 is really easy because our number system is based 10 system. Like using the 10 frames, if you fill up the 10 frames, you can easily count what is left over, what is not in that 10 frame. So you can usually easily find what number it is. For example, 9 plus 7, you just need one more to make 10. So you're gonna regroup 7 into 1 and 6 because you need 1. And then you're gonna use, this is associative property because we're not changing the order. It's still 9 plus 1 plus 6. And here is also 9 plus 1 plus 6, right? But in this case, you had 7, which is 1 plus 6. But now I'm going to associate these two to make 10. So I'm associating 9 and 1 together to make 10 and 6. So it's called associative property. We're going to talk about that later. Just a heads up. Okay? And going back to doubles, the same thing. 6 plus 7, and 7 can be decomposed into 6 and 1. Why? Because I like to have a double number. So if I change 7 into 6 and 1, I can associate 6 and 6 because I know 6 and 6 is 12. So 6 and 6 is 12 plus 1. That's 13, right? Or you can change it, this number into making 10. Then you can change 7 into 4 and 3 because I need 4 to make 4 to add to 6 to make 10, right? So if I change that to 4 and 3, 4 and 3 is still 7. 4 plus 6, 6 plus 4 will be 10, and I have 3, so it's 13, still the same number. So you can use any of the techniques for exactly same question. Okay, this is 10 frame, heads up. So if you have 8 already, because if you fill up this 10 frame, it's gonna be 10 to make 8, 2 or less. 2 less than 10 is 8. So we know this is 10. To make 10 frame, I just need to have 2 more than what is left. 4, right? So 4 will be out there. So I have a 10 and 4. 8 plus 6 will be 10 and 4, 14. Does it make sense? Okay, so let's have some examples. Okay, so if I do some examples using counting on, doubles, and making 10. Okay, can I erase this out there? I think it's taking time. So, oh, here's a clear frame. Sorry. Okay, I knew that there is something like that. And let's have some examples. Let's suppose we are adding a plus 6. Okay, so if we are using counting on, I know that I have 8, so I'm gonna add on using my fingers. 8, 9, 10, 11, 12, 13. That's my one hand, and I have my thumb. 14. Right? That makes 6. And I have imaginary fingers here. This is my thumb. Okay, so I have 6 here, and I already had 8 in my mind. Right? And I counted on from 8. 9, 10, 11, 12, 13, 14. So 8 plus 6 is 14. If I use doubles, I can do 8 plus 6 as, well, you cannot change the 6 to 8, right? But I can do 6 and 6 as a double. So I'm going to change 8 into 2 and 6. 2 and 6 is 8. You still have a plus 6. So we can associate these two together using associate property in addition. So I can do 6 plus 6. I know 6 plus 6 is 12. So we can have 2 plus 12, which is 14. Same number, isn't it? If I use making 10, I know 8 needs only 2 more. So I'm gonna decompose 6 into 2 and 4. 2 plus 4 is 6, right? Now we decompose 6 instead of 8 in the previous example. So if I use associative property again, I can combine 8 and 2 together. Quality doesn't change, it's still equal. Plus 4 is equal to, this is 10 and 4, so it is 14, still the same number. So here are some techniques that we can think about, and your students always can think about their own invented strategies. So please have an open mind and accept them. And they can always, develop their understanding from there. Now we're gonna talk about some properties. What properties do you remember? Pause the video a little bit and think about it. Do you remember all of the properties for addition? Do you understand all of the properties you just recited? Let's review a little bit. Closure property of addition. Closure property of addition means if you have any two numbers or two or more numbers, they are whole numbers, then the addition, the sum of those two numbers have to be also whole numbers. Okay? So for example, let's go to the next page. If we are adding 2 plus 3, 2 is a whole number. So if I use the set notation, we are back to Math 137. 2 is an element that belongs to whole number. Whole number is W, okay, capital W. 2 is an element of a whole number. 3 is also a whole number, right? So each of these add-ins are whole numbers, then their sum should be also a whole number. Okay, a unique whole numbers. Alright, that is a closure. Hey, when doesn't make it true? Well, it makes true for all whole numbers. But if you are having different numbers like integer, -2, it's not a whole number, right? So we're not gonna have that into closure. So for addition, pick any two whole numbers, you add them, it's always a whole number. For example, another example, 2 is a whole number, 0 is also a whole number, you add them together, 2 plus 0 is 2. Yes, it is a whole number. So whichever whole numbers you're picking and adding them together is always a whole number. So closer works. Closer property works. Okay, but in the subtraction later, oh, you need to think about it. It doesn't work for every whole number. Okay, commutative property. When we are talking about commute, what does a commute mean? I commute. What does that mean? You go home, you go to work from home, or the other way around. So commute means you go from here to there. Commutative property is very similar. Commutative property in addition, of whole numbers. Even if you are switching them around, equality doesn't change. For example, 2 plus 3 is equal to, switch them around, 3 plus 2. The quality doesn't change. It's still 5. 3 plus 2 is 5, right? So commutative property works for the whole numbers. Next one is associative property. Associative property in addition. Yes, you can associate things. So when you have more than two numbers, for example, let's have 2 plus 3 plus 4. In this order, you're going to add these two together. So you're going to do 5 plus 4 is equal to 9, right? How about we're not changing the order? We're not changing the order, so it's not commutative property, but we are not adding these two first. But we're going to add these two first. So we have 3 plus 4 as 7, and you are adding without switching the order, and that is still 9. So associative property works. Okay. Oops. What's next? Identity property. Identity property. Identity. If I ask you what is your identity, what would you say? You're going to talk about yourself, right? Identity. So it's yourself. For example, if you have 2 plus something, you're going to be yourself. What do we add? Yes, when you add 0 to it, you always get yourself. So whatever number, when the number is a whole number, you are adding that by 0, you get yourself. Okay, then that is identity property in addition of whole numbers. Okay, all right, what's next? Which property is the best to solve the addition mentally? 18. Let me copy this down here and let's solve this together. Oops. It's not working. 18 plus 7 plus 2. 18 plus 7 plus 2. While I'm writing this down, I want you to have some time to solve this. 18 plus 7 plus 13. 7 plus 13. Okay. To solve this, what do you see here? What are the easy numbers if you are doing this mentally? I'm going to write this here, but you can think about this mentally, okay? I'm just writing that down. Oops. Our mental process here. I can see that, 18 and 2 is really good number to go together, right? So, hold on. Okay. Something went wrong. My cursor doesn't go back. Okay, here we go. Okay, so 18 and 2 makes a really good easy number, right? Because it's 20. We know that 8 and 2 makes 10, and 18 plus 2 is 20. So I'm going to move this here, move that here, by switching these two around like that. So I switched the 7 and 2's orders, which is still the same. What property is that? I switch them around. So yeah, it is a commutable property, right? Then I can add these two together, which is 20, and I still have 7 there, which is 27. Okay, so commutable property of addition. How about this one? Oh, I see 7 and 13 to make 7 and 13 is 10, but 13 plus 7 is 20 then. So I'm gonna add these two before I add these two together. Instead of adding them together. So what I'm gonna do is I'm gonna add these two together instead of these two. So what property do I use? Yes, it's associative property. I didn't change the order. No, it's still 18, 7, 13. 18, 7, 13. Order didn't change, so it's not commutative property, but I am associating differently. So it is associative property. Okay? So 18 plus, what's 7 plus 13? 20. Now, this is 38. You can do this mentally, okay? So without looking at all these procedure, you can say that, oh, 18, 7, and 2. I know 18 and 2 is 20, 20 and 7, 27. 18 plus 7 plus 13, 7 and 13 is 20, 20 and 18, 38. Okay, you can do that mentally. So that is the mental procedure using the property that we learned. Okay, what is next? Addition algorithms. Now, students know how to use some manipulatives or other models, their own strategies. Then they can have the shortcut, right? So addition algorithms that we already know as a standard algorithm is the shortcut that we can introduce to our students, so they can save a lot of time, right? But before you introduce that algorithm, using manipulatives like base 10 blocks really helps them understand better. So for example, if we are doing 14 plus 23, let's use base 10 blocks. 14. So this rod is 10. So because these small cubes are the units, right? So 1, 2, 3, 4, and you have 10 of them, which is 1, 10. So this is 1, 10, 4, 1, 10, 2, 10, 3. So 23. 1, 10, 10, 4, 14. Right? So when we are adding them together, we can write it this way: 14 from this set, 10 and 4, 10 and 4, 2, 10, 10's place is here and 1's place is here. You are adding the ones together, 4 and 3, 7, 1, 10, 2, 10 together, 3 10s, which is 30. It's not 3, it's 30 because it's 3 10s, right? So it's 30. 7 plus 30 is 37. And they can see that 1, 2, 3 rods, 1, 2, 3 rods, 3 10s, and 1, 2, 3, 4, 5, 6, 7 ones, so 7 ones, right? That's expanded algorithm. From there, you can introduce, well, 4 plus 3 is 7, and 1 10 plus 2 10 is 3 10. That's standard algorithm. Well, there was nothing carried over, so it was simple. But what if we have a bigger number? For example, if we are adding 100, $60, that's 50, 60, 1, 2, 3, let me see if I can do it faster, 4, 5, 6, 7, 8 plus 1, 2, 3, 30, 1, 2, 3, 4, 5. Okay, so what am I adding is 100. Doesn't let me write. 100. Okay. I don't understand this. 100. Come on. Can you write it? Okay, it's working. 1, 2, 3, 4, 5, 6 10s. 60. 1, 2, 3, 4, 5, 6, 7, 8. 8, and there are 3 rods and 5 ones. So what I'm adding here is 168 plus 35. Where do I write 3? Yeah, right underneath tens place. So this is ones place, tens place, and hundreds place. So we need to line up 3 tens and 5 ones. When you have more than 2 digits, I suggest you to use your notebook. Or you can ask your students to use notebook, not horizontally but vertically. So you can have lines for, this way, vertically. Then they can line up their numbers easily. Okay, so for this, what do we do? Well, we need to know that when you have 10 ones, you can regroup that as 1 tens, right? So for this, I can combine these two together and regroup this as 110 because it's exactly the same amount, right? So I'm gonna add this one here, and I can delete all of this. I'm just regrouping it or trading it. Okay, right? And I can erase this too. Okay. Now what do we have left here? 3. So I have 13 by adding 8 and 5 together. So you can explain that to your students by writing 13, the 10 and 3, as 3 is right there. Where did that 110 go? It's not written anywhere, so we can say, it's a tens place and 1 more rod. So you're gonna write 1 more rod right above the tens places, right? And then we're gonna count how many rods there are all together. We can see 1, 2, 3, 4, 5, 6, 7, and 3 more. That makes 10 rods. When you have 10 rods, what do? We can regroup all of that with 100, right? 1 flat. So that goes in the hundreds place. So all of these are gone and there's nothing left. Nothing left. So I have 0 here. Oops. I have a 0 here, no rods left because I traded all of these rods with 1 new block, new flat. So how many flats do I have? I have 1 more flat added. Now I have 2 flats, which is 2 100s, right? Now we can see that, there are 203. 100, 200, and all of these are gone. You can either cross it out or you can literally erase them all, okay? Either way, it works. And what is left? You have 3's in the ones place. So you have 200, 0, 3, 203, okay? So yeah, using manipulatives really helps for them to understand the expanded algorithm and standard algorithm too. Okay. So let's try 18 plus 5. Here, 18 plus 5. We can have 10 and 8. Oops, this is not tens place. That's ones. That's hundreds place, right? Okay. So 18, 110. And 8. 1, 2, 3, 4, 5, 6, 7, 8. 18 plus. Did I say 5? Yeah. Let's see here. Plus 5. 1, 2, 3, 4, 5. So I have 18 plus 5. When you're adding them together, what happens? what we can do is we can move this. Oopsie. No, it's all gone. Let me do that again. 10. Yeah, some manipulatives, virtual manipulatives, I don't like. But this is what I found as the best one. I think I still need more time to get adjusted. Okay, 18 plus 5. 1, 2, 3, 4, 5. Okay, the young people like you, I know you can do it better. Okay, 18 plus 5. You can rewrite that as 18 plus 5 here. 18 plus 5. When we add these two together, what happens? Well, for 8, if you move these two here and combine them together, that makes 10 ones. So we can regroup this whole thing with 1, right? So I'm going to have, what I'm going to have is one more 10 rod, one 10 rod, and how many is left? There are 3 left. So I can say, oh, there are 3 left. Now how many 10s do I have? I have 1 10, 2 10, 1 10, 2 10. So 2 10s, that makes 23. Okay, so you can use the columns. Okay, and you can also do 37 plus 28. Since I did like hundreds digits already, 3 digits, you can do that. I'm not gonna show you, but you can try this in your virtual manipulatives or physical manipulatives. Okay, think about using the word regrouping. I said regrouping or trading instead of saying carrying or borrowing. We didn't do anything like that, right? Carrying is not correct because we didn't carry it over. We traded, we regrouped it, right? So you need to use a correct terminology. Later in subtraction, do not say borrowed because you're not gonna pay back, all right? That's wrong terminology. So use regrouping or trading, okay? So expanded algorithm and standard algorithm, we talked about that too. So you can use both concrete model and standard algorithm to solve 3 digits of addition too. So I will let you do that. I already showed you, right? So if I do that, hold on, using my Jamboard, 186, 127. Okay, 186 plus 127. Okay, you know how to use the manipulatives, so I'm going to use standard algorithm here. So when we are adding the numbers together, if we are doing mentally, we usually start from bigger digits like hundreds, tens, then ones. But when we are using the standard algorithm with a pen and pencil and paper, we're gonna start from the ones place because we need to do the regrouping procedure. 6 plus 7, whichever strategy, like doubling or counting on, or whatever, you can find it out. 7 and 6 is 13. So 13. In 13, that 10, 110 is in tens group. So you're gonna put 1 that we regrouped here, the ones, right, goes up here. So now we have 8, 2, and 1. 8 and 2 makes 10, and we have one more tens rods. So we have 11. But that is 11 rods. That's why it is 100, right? Because it's 11 rods, that 100 group goes up here. Now we have 300s. 313 is the answer using the standard algorithm. Okay. Now, partial sum algorithm. Partial sum algorithm is expanded algorithm. So, for example, 5, 6, 8, 7, 5, 6. 500, what was it? 5, 6, 8 plus 757. 757. Okay, I will show you both ways. Okay, 757. I will use partial product first. Not partial sum, not product. I keep saying product, I'm sorry, sum. Okay, so the answer of addition is sum. Answer of subtraction is difference. Right? What is answer of multiplication? That's product. What's answer of division? It's quotient. Okay? Alright, so partial sum means you're gonna use partial sum. So not complete sum, okay? So you're gonna add ones, tens, hundreds all separately. What's 8 plus 7? That's 15. What's 60 plus 50? Which is 110. What's 500 plus 700? This is not 5 plus 7. You need to make sure when you're teaching your students, this is 500 plus 700. So it's hundreds. How many hundreds are there? 5 and 7. 13 hundreds are there. 12 hundreds are there. Right? So these are partial sums. And then you can add all of them together. 5 ones, 2 tens, 3 hundreds, and 1 thousands. So we read this as 1,325. If we use standard algorithm, we can do 8 plus 7 as 15, and we don't write 1 here, 110 here, but it's up here. So 15. And now we have 1, 6, 5, many tens. So 6, I'm gonna just put 1 and 5 together because I like double, which is 12 tens. 12 tens. And I have 6 and 7, and 6 and 6 is 12, and one more, so 13 hundreds. So it's gonna be 1,325. So you need to know all of these methods, okay? That's partial sum product. And in your homework example, it's asking to give reasons for each of the following steps. So we're gonna talk about this, okay? So you're given all of these properties here: associative property of addition, closure property, commutative property, associative and commutative, distributive. We didn't talk about distributive property yet. Briefly to say, distributive property is you're distributing. Distributive. So for example, if we are doing 2 times 3 plus 4, you can distribute 2 to each of that numbers, the add-ins here. So 2 times 3 plus 2 times 4. It's a circle. 6 plus 8, right? And that is 14. It's same as 2 times. Well, if you are using order of operation, you want to do parentheses first. So 3 plus 4 is 7. 2 times 7 is 14. Same number. But you can use the distributive property there too. Okay, so that's distributive property. And identity property, we know you make yourself by adding by 0. Place value, we know whether it is tens place, hundreds place, thousands place, and so on. That's place value. Single digit addition facts, we know like 3 plus 2 is 5. Those are single digit addition facts. So let's take a look. Get 143 plus 22. 143 is expanded into 1 times 10 squared because it's hundreds place. 1 is hundreds place. 4 is tens place. 3 is ones place. This 2 is tens place. This 2 is ones place. So it shows what? It's showing, place values. What 1 means? 1 means 100. So 1 times 10 squared. What does 4 mean? It's 40. So it's 4 times 10. So that is a place value. Right? So you can put place value here. How about this one? 1 times 10 squared plus 4 times 10 plus 2 times 10. What happened? 2 times 10 was here, but now it's here. So it is switched, right? And this went here. So these two are switched, but not only switched, but also they associated differently, right? So it is associative property and commutative properties, both. So we can have the same digits together. So hundreds digits, tens digits, and ones digits, right? So 1 times 10 squared. Here, what happened here is, because 4 and 2 are both multiplied by 10, you pull that out. Here, 4 plus 10, and factor the 10 out. So it's backwards of a distributive property. If you are looking at this part first, you can see that easily. 4 plus 2 times 10, you can use distributive property to do 4 times 10 plus 2 times 10. That's up here. So either way, it is distributive property of multiplication over addition. Okay? Okay, so that is what happened here. Everything else is exactly same as the step 2. And step 4 from step 3, it's still the same, and they did 4 plus 2 as 6, and they did 3 plus 2 as 5. They just added. So it's a single digit addition fact, right? And then you can do 1 times 100 is 160 plus 60 plus 5. Okay? So I don't think it's gonna ask you about that for the last part. So that's good. And here's another homework example. Let me make it bigger. Okay, to find 9 plus 12, a student says she thinks 9 plus 12 is 9 plus, instead of 12, decompose 12 into 1 and 11, right? And then added 9 and 1 first to make 10, then added 11. What property or properties is she using? Pause the video and think about it and come back. So yes, from here to there, the order didn't change. 9, 1, 11, 9, 1, 11. So it's not commutative property, but they associated differently. Here, 1 and 11 was associated, and now 9 and 1 are associated. So associative property, right? So let's see which one says the same thing. First, she used the commutative property. No, right? Separate 12 into 1 and 11. No. Separated 12 into 1 and 11 with identity property of addition. It's decomposing. 9 and 1. So she separated 12 into 1 and, yeah, so first she separated 12 into 1 and 11. That's not identity property, right? Identity property is when you add by 0, you get yourself. So it's not, it's just decomposing. So first she decomposed or separated 12 into 1 and 11. Then she used the associative property to get 9 and 1 together. 9 and 1 together instead of 1 and 11 together. Next, she added 9 and 1 to get 10. Then she added that 10 and 11. So answer should be C. Okay, in the video, we're gonna watch the video in that homework example. Andrew finds the sum of 120 and 96 in a similar way. Okay, so this is what Andrew find the sum of 120 and 96 in the video. 120 plus 96 decompose 120 into 120, 96 into 96, and then 120, 96. Oops. 120, 96. The order didn't change, but how he associated it has been changed, right? So using the associative property, Andrew combined tens together and hundreds separated, and each digit has been separated, but tens are together. And then what he did, used the commutative property. I don't know why, but he did. And then what did he do? And then associated differently because the order didn't change, right? And added 190, then decomposed 20 into 10 and 10 to make this as 200, right? And associated differently here, So instead of adding these together, added the first two together, associative property, and got 210 and 6 and 206. Okay, identify which lines represent where Andrew is using associative property. Where did he use associative property of addition? From here to there? Did he associate differently? Not really. 190 plus 10 is 200, and then he added 10 and 6. So no, did not associate it differently. It's exactly the same thing. How about here? He was supposed to add 90 and 20 first, right? But the order didn't change, so it's not commutative property. Anyways, instead of adding 90 and 20 first, he added 190 together by associating the numbers differently. So this is associative property. How about this one? Because it says select all that apply. 190, 10, 10, 6. 190, 10, 10, 6. Yeah, so it is not commutative property. It might be associative property. So let's take a look. Instead of adding 10, 10, and 6 together, added 110 first, then 10 and 6. So yes, it is associative property. How about this one? Switch the numbers around, so it's a commutative property. So the correct answer should be B and C. Okay, that's all for today, and you're gonna have part 2 in the next video. Have a good day, guys.